What's up, guys? Hope you're having a good first day of digital learning. Today, to be honest, should be pretty easy for us. We're going to learn about a special case when we're factoring called difference of squares. And it's going to be exactly what it sounds like. You've got two perfect squares being subtracted, right? In math, whenever we say difference, we're talking about subtraction. And we're subtracting two perfect squares, right? A squared and B squared. So here's kind of the general example. Um, and then we'll jump into some actual real examples. And this is going to be where it starts to make a lot of sense for you guys. So, in general, when you have a perfect square minus a perfect square, that's going to factor into a binomial times a binomial, right? A plus B times A minus B, where A is the square root of A squared, right? That's that first term. B is the square root of B squared, that second term, right? Notice how these are the same in each one of them. The only difference is one of them is being added, the other is being subtracted. And to be honest, that's as simple as it is. So as we start working these examples out, I think you'll see how these can tend to be pretty easy once you get the hang of it. So let's look at this first example. Um, X squared minus 16. So, like I've been saying, we have a bunch of different examples of factoring kind of floating around in our brains, and we got to be able to know like how to tell when to use what type. So obviously, this is going to be a difference of squares because that's the lesson. Um, but let's make sure we know how to like identify a difference of squares when we see it. So the first thing we got to make sure is it a difference, right? Difference means subtraction. So yep, we do have a difference. And is it of two perfect squares? Well, x squared is x times x. So yeah, that's a perfect square. 16, that's 4 squared. So 16 is a perfect square as well. So we have a difference of squares. So like we saw up here, whenever we have a difference of squares, that's going to factor into a binomial times a binomial, right? And we're going to take the square root of each one of these terms. So the square root of x squared is x. The square root of 16 is 4. We're going to put one of those in each. And notice from the formula, one of those is going to be added. Sorry, that was rough. Trying to draw with my mouse right here. One of those is added, and the other one is subtracted. And if you were to multiply x plus 4 times x minus 4, you should get x squared minus 16. And if you don't believe me, try it out. Let's look at this next example. Notice how this one's a little different in that our first term has a coefficient with it, right? So again, we're trying to make sure that we've got a perfect square minus a perfect square. And if you notice here, we do, right? 4 is a perfect square, right? 2 squared is 4. Obviously, x squared is a perfect square. And 25, that's 5 times 5. So we have a difference of squares here. So we know we can factor it into a binomial times a binomial, right? The square root of 4x squared, well, the square root of 4 is 2. The square root of x squared is x. So I'm going to need a 2x as the first term in both of those. Square root of 25 is 5. Weird looking 5, but we'll roll with it. And now, one of them has to be plus, one of them has to be minus. And if you were to multiply this times that, you will get this, right? The square root of 4x squared, 2x. Square root of 25, 5. And when we factor that difference of squares, one of them has to be plus, one of them has to be minus, right? And as you guys know, the order of which one of these binomials goes first doesn't matter, right? As long as what's inside is correct. So, hey, now's a good time. Pause the video, try out these two examples down here, and see if you're able to do these on your own. So go ahead and pause it now. All right, hopefully you paused the video and you tried these out. Let me go ahead and write down the answer for each, and let's see if you got it right. So x squared minus 4, we've got a difference of squares, right? Both of these are perfect squares. When you factor, you got two binomials. Square root of x squared is x. Square root of 4 is 2. And y'all know one of these has to be plus, one of these has to be minus. Hopefully you got it right. If not, it's okay. Keep trying. Let's look at the example. Let's look at the answer for this one. So difference of squares. Yep, 9 is a perfect square. X squared is a perfect square. So we're good here. 49, that's 7 squared. So we got ourselves a difference of squares. We know it's going to be a binomial times a binomial. Square root of 9 is 3. Square root of x squared is x. Square root of 49 is 7, right? Weird looking 7. Let's give that another try. And I know I'm going to need a 3x and a 7 for each. One of them has to be added. The other one has to be subtracted. Hey, if you got them both right, you're awesome. If not, you're still awesome. Maybe you just need a little more practice. So either way, go to Canvas now, go to the same module with today's date and look for the practice that's going to be in there. I'm grading it just off effort, not accuracy. Just give it a shot. Shouldn't take you too long. And after you finish that, you're done for the day. Hey, if you have any questions about anything that we're doing on here or anything in general, email me, send me a message in Canvas, send me a message in Remind. If you're not signed up for our Remind, go ahead and get signed up for that. I sent a message on Friday, so go to your Canvas inbox, click the link, and get signed up. That's going to be kind of a really good way to kind of keep in touch over this kind of 2-week break. So hope you'll have a great rest of the day.